My name is Kelly Powell, Technical Manager for Inveno Engineering, LLC. We are a domestic and international engineering firm focused totally on steam and condensate systems. Today, what I want to talk about is what really increases or decreases boiler efficiency, which is a part one of a two-part series. Items that affect boiler efficiency. What are the items that affect boiler efficiency? Flue gas losses, radiation losses, blowdown, surface and bottom blowdown, combustion air temperature, feedwater temperature, deaerator operation, condensate recovery, and steam venting. Example, a boiler operating 150 psi. All water coming into the boiler must be raised to 366 degrees Fahrenheit, or phase change temperature. Higher steam pressure will equal higher flue gas temperatures. So if I'm operating at 150 psi, 366 degrees, the flue gas temperatures are going to be 466 degrees or higher. Typically we say 100 degrees more than the saturation pressure temperature correlation. If I operate a boiler at 100 psi, and then the saturation temperature at 100 psi is 338 degrees or 438 degrees. So operating pressure does affect the flue gas temperature. The biggest loss in any boiler operation is flue gases going to atmosphere. It can be as much as 20% of your losses. So 20% of your fuel budget is going up the stack. So we have to be very critical of that loss. The combustion flame temperature, a rule of thumb, it depends on the burner, 2,850 degrees Fahrenheit. All air coming in for this combustion process has to go up to 2,850 degrees. So we have to be very aware of excess air levels in the combustion process. Lower excess air. Less air I have to heat up to 2,850 degrees. Remember one thing, the combustion is not looking for air. It's looking for the oxygen in the air. So we just have to heat the rest of it, the nitrogen, up to 2,850 degrees. Flue gases on average, so I was saying, 16 to 22% loss. What affects the flue gas losses? BTU output, steam. If I need more steam out in the plant, I need more BTU input coming into it. And need the air-fuel temperature relationship. Higher output's going to be higher input. More fuel coming into the boiler, more flue gas volume going out the stack. So we don't have control over that. We need to provide steam to the plant so they can make a product. The combustion process, temperature, and excess air. The thing we can really control is this excess air. The thing I was talking about, flue gas losses, the flue gas heat recovery. Standard economizer, 3 to 4% efficiency gain, depending on the economizer design. Condensate economizer can gain 8 to 12% efficiency. And the thing with condensing economizer, you have to have the system that can utilize the condensing economizer. The boiler operations we look at, probably there's only 30-35% of these boiler plants can implement a condensing economizer. Air heater, preheat the combustion air. I said all the air coming into the boiler has to go up to 2,800 degrees. So we preheat the air to, lessen that temperature differential. But preheating air is usually done on new boilers, not existing boilers, because of the cost to implement it. Action today, trend flue gas temperatures and review heat recovery opportunities. What we want to do is reduce those losses. One of the easiest ways we can reduce the losses is burner fuel air ratio curves, understanding the burner fuel air ratio curve. The combustion control system controls the fuel air ratio curve. Lower firing rates will have higher excess air levels. So the blue line is showing you basically what an optimal fuel air ratio curve looks like. The red line is where we typically find the fuel air ratio curve. Higher than the optimal. Reason being, there's a number of reasons which I won't get into. But the thing about it is you have to understand where that curve should be and making sure you're setting combustion to that curve. If you can't get to that curve because of limitations, then you need to correct the limitations. So you need to have a qualified person on staff or a qualified outside vendor that can set these combustion control systems to that optimal fuel air ratio curve. One of the things that we come across is this here. These are ticker tapes from a combustion analyzer. It's really, I call it substandard combustion testing. It is, not what we want to be looking at. What we want to be looking at is this here. A fully documented combustion testing data sheet. This is a data sheet that should be filled out during combustion testing and provided to you at the end of the combustion testing. All data to be filled out during the combustion testing. And, we do a as-is combustion testing and fill all the data out, and then we adjust to get the optimal fuel air ratio curve. So we have another data sheet that's filled out. So just make sure the person coming in is filling out these data sheets. Understanding the burner fuel air ratio curve. If you're running at, let's say, 6.6% oxygen, what does that mean? 44.8% excess air. 44.8% more air is being added into the combustion process than is required. So you're heating up a lot of nitrogen and all that additional air, which is more volume of heated air going out the stack. So if you get down to the optimal fuel air ratio curve, which is 3.6 or whatever it is, then you're at 20.2%. So you cut the excess air by over 20-some%. Testing conducted every 6 months minimum by a certified combustion engineer, either on staff or outside vendor member. A person needs to be certified to do this type of work. It can save you a lot of money. Combustion efficiency needs to run like a R8 throughout the firing range. So make sure your boiler is running like a R8. So here's a combustion flame, perfect. Everything. And the other thing that's important is looking at combustion flames can tell you how you're operating. Something to check every day. Just said flame pattern, throw temperature, color. Every boiler operator or every person, first thing you come in the boiler room is to look at the combustion flame. It tells you a lot about what's happening with the combustion process. And it doesn't take that much time. Question, what happens on Monday? One of the first things I want to do is, look at the combustion flame, for sure. The second thing is look at the fuel air ratio curve, see where the optimal curve is and where I should be operating at. Next thing is I'm going to be profiling the thermal losses or flue gas temperatures out of the boiler. The other thing is that there's 70 best practices up at our website, 28 articles and 24 instructional videos, and we'll continue to update and add more to our library content. There are technical papers like you see here on the right-hand side available for your download. We do partner with our clients, short-term impact, steam system engineering assessment, steam system balancing, steam system reliability, and steam system engineering training. Long-term implementation engineer, project design, project management, and full engineering support and system changes. My contact information is here. Please visit our website, www.invenoeng.com, and my email address, as you can see here. Please email me if you have any questions regarding steam systems, boiler operations. We're here to help you. Have a great day.